What do Google Search, ChatGPT, Spotify recommendations, and fraud detection systems all have in common? They run on a silent, invisible technology that helps machines understand meaning, not by words, but by numbers. Embeddings. They're the hidden engine behind modern AI, shrinking massive ideas like language, images, and behavior into small vectors that make sense to machines. Today, we're going to uncover what embeddings really are, how they work, and how you can use them even without deep ML background. What are embeddings really? Embeddings are simply numerical representations of data, usually in the form of high-dimensional vectors. Instead of storing cat as text, image of a cat as pixels, or a user's transaction history as rows in a table, AI transforms each into a dense vector of numbers. Why? Because in math space, meaning becomes measurable. Cat and kitten live close together. Cat and dog are nearby, but not identical. Cat and airplane are miles apart. And that's the magic. Distance becomes meaning. Why embeddings matter. Embeddings allow AI to perform. Semantic search. Search by meaning, not by keyword. Example: search eco-friendly bottle alternatives. Embedding systems can show stainless steel and bamboo bottles even without the keyword alternatives. Recommendation systems. Netflix, Spotify, Amazon, all powered by similarity between vectors. Fraud detection. Abnormal user behavior leads to a vector that doesn't fit the pattern, leads to automatically flagged. Document clustering. Group content by topic automatically. You could organize an entire library without reading a single page. AI memory systems. LLMs retrieve relevant chunks using embeddings, not raw keyword matching. How embeddings work under the hood. High-dimensional geometry. Embeddings often live in 128, 512, or even 4096 dimensional space. Imagine, each dimension captures a nuance, sentiment, context, structure, style. Training through prediction tasks. Models learn embeddings indirectly by predicting something. Next word, word to vec, GPT. Masked word, BERT. Image classification, ResNet. Contrastive learning, CLIP. As the model learns, the embedding layer starts to cluster similar concepts together. Vector similarity. Machines compare vectors using cosine similarity, Euclidean distance, dot product. This is how a model answers. Which document is closest in meaning? Practical, real-world examples. Semantic search for a company help desk. A user types, "Laptop battery drains fast." The search engine returns your article titled, "Why Your Device Loses Power Quickly." No matching keywords, but the embedding vectors align. Movie recommendation. Your friend loves Interstellar. Embedding systems map what makes it special. Sci-fi, emotional depth, time/space themes, soundtrack tone. Then find movies with similar vector signatures. Detecting abnormal behavior. A user normally spends $20 per transaction. Suddenly, a $1,200 purchase. Their behavior vector shifts, triggers anomaly detection. Using embeddings in LLM apps, low code. With Naden, LangChain, or Flowise, you can build Q&A over documents, chatbot with memory, idea similarity matcher, all using embeddings plus a vector database like Pinecone, Weaviate, ChromaDB, or Elasticsearch. Building your first embedding project. Let's build a small project to see how embeddings work. I am using Python. I will share the code in description. First, install the required libraries. This is the code we are running. I will explain the sections. We need data. We're using the Wikitext 103 dataset, millions of real sentences from Wikipedia. It's perfect for building a realistic search engine. Since processing millions takes time, we will limit the dataset to only 100,000. This is where the magic happens. Embeddings are numerical fingerprints of text. This model outputs a 384-dimensional vector per sentence. Then, the longest step, convert all notes into embeddings. Next, we use Face-CPU, a library developed by Facebook AI Research for efficient similarity search and clustering of dense vectors, optimized for CPU usage. Then we do the search. Instead of keyword search, this system understands meaning. Let's run the code and see. Ask what is a black hole. It gives related answers. Explain football rules. Who invented internet? Tell me about history of AI. It even figured out AI is artificial intelligence. Unlike keyword search, this finds meaning, even if your question uses different words. Imagine each sentence is a star in space. Embeddings place similar stars close together. When I want to search, it also places the question in the sky. Searching is simply finding the stars nearest to your question. Embeddings are the unsung heroes of AI. They allow machines to understand context, connect ideas, and mimic human intuition. If you're building anything with AI, a chatbot, a knowledge base, a recommendation engine, embeddings are your secret superpower. The future belongs to those who understand them. If you found this video helpful, hit the like button, subscribe to the channel. Thanks for watching, and I'll see you in the next one.